All right, week number 15. 1 second here for 1 second. Sorry about that. I had to sneeze. Okay, week number 15 is the last week for the 2021 school year, the live class, because we don't meet until January 3rd of next year. So pretty awesome. This week, we're going to be talking about the second derivative test, which is really fairly easy. If you understood the first derivative test, the second derivative test is going to be really pretty simple for you. And this week, as I said, our main lesson is today. And then you have all the way until next week, Wednesday, to turn in your stuff. And it won't be counted as, well, nothing's counted late, so it really doesn't make any difference. But the due date is not until next week, Wednesday. Next week on Monday, we don't have any main lesson because there's no new material. So if you get everything done today, like you normally do, you are done with calculus until February 3rd. All right. This week, we're going to be working on concavity and the second derivative test. What is concavity? If you drew a parabola, this is considered the concavity of a function. So this is concave up, this is concave down. I am talking. You still can't hear me? Okay. Oh, shoot. All right. So this is concavity. This is called concave up. This graph here is concave down. And if you take a look here, this is concave up, and this is concave down here. So where it switches, we call that a, they don't have it right there. That is called a point of inflection. Okay, so that is called our point of inflection when it changes from concave up to concave down. So how do we find points of concavity? Well, we take the second derivative. If the second derivative is greater than 0, the function is concave up. If the second derivative is less than 0, the function is concave down at that point. So it's going to be almost identical to what we were doing last week, except this time we're going to use what is called the second derivative test. So we're going to take the second derivative. So in this problem, and this is a problem off of your assessment this week, it says use the table below to find where the function is concave up or down and any inflection points. Okay, so if I was going to do this problem, I would say that, so I'm going to turn my marker on here. That it's going to be concave up here. It's going to be concave down there. It's going to be concave up all the way along here. And then it's going to be concave down here. So if I'm going to do intervals, I'm just going to say from -infinity to -10, from 2 to 10, and I really should have, because it's infinity, 2 to 10 would be all concave up. And then concave down would be from -10 to 2 and 10 to infinity. And then where are the inflection points? Well, the inflection points are the points where it does change. So there is an inflection point at x equals -10. There's one at x equals 2. There isn't one at 4 because it doesn't change concavity. And then there's one at x equals +10. So this is and this is supposed to be a second derivative table. So that's what we're going to be making today. We're going to be making the second derivative table up, and that's what it's going to show us. It's going to show us where functions are concave up, concave down, where the inflection points are. So when I used to teach face-to-face, this is the type of problem that kids would walk in, I'd hand them this. It's like, okay, I want you to fill in this whole thing. So in this whole diagram here, it's asking what is the local max, local min, intervals where it's increasing, intervals where it's decreasing, intervals where it's concave up, concave down, inflection points, make a sketch of the function. Okay, so if this is my function here, f of x is equal to x to the fourth minus 2x squared. First thing we're going to do is we're going to take the first derivative, and that's going to be 4x to the third minus 4x. I'm going to factor out a 4x here, so that gives me x squared minus 1. So that gives me, if I keep, that's x minus 1, x plus 1. So my first derivative test, now this is first derivative test, I've got 0, 1, and negative 1. So I'm going from negative infinity to negative 1, negative 1 to 0, 0 to 1, and 1 to infinity, which I can't fit on there. So again, we don't need to know the value. We just need to know if it's positive or negative. So I'm going to take negative 10 here. So if I take negative 10, I find that 4 times negative 10, that's going to be negative. Negative 10, that's negative. Negative 10 plus 1, that's negative. So negative times negative times negative, that is definitely negative. I know it's decreasing here. Negative 1 to 0, I might use negative 1/2. So that would give me negative here. Negative 1/2 minus 1, that's negative. Negative 1/2 plus 1, that's positive. So I've got negative, negative, positive, which is going to be positive, so it's increasing here. 0 to 1, I might take 1/2, so that would give me a positive here. Negative here, positive here. Positive, negative, positive is negative, and then this is going to be positive here. So decrease, increase. So that is my first derivative test. And obviously, if it's decreasing then increasing, then at negative 1. So here, local max at x equals negative 1, that's min. So at x equals negative 1, we have a minimum point. Then it increases and decreases. So at x equals 0, we have a max. And then decrease and increase. So at x equals 1, we have a minimum. Intervals in which the functions where it's increasing, and I can just write these in here, negative 1 to 0, and I think it was 10 to infinity. It's increasing. Where is it decreasing? Negative infinity to negative 1, and 0 to 1. Okay, so that takes care of the first derivative. It tells me where it's increasing, decreasing. It also gives me max and min points. Now the second derivative, okay, so I'd have to find the second derivative. And the first derivative, let's see here. So this is the second derivative, or the first derivative. So the second derivative is going to be 12x squared minus 4. So I'm going to factor out a 4. So that leaves me with 3x squared minus 1. That's not going to be nice. But I'm just going to set this equal to 0. So 3x squared is equal to 1. So x squared equals 1/3. So this is going to be the square root plus or minus the square root of 1/3. So now my second derivative test, I've got so negative infinity to negative square root of 1/3. Then I have negative square root of 1/3 to square root of 1/3. And then I have I need to write these things smaller. And then I'd have the square root of 1/3 to infinity. So if I did this, again, it doesn't matter if this is negative square root of 1/3. All I have to do is take a number that's smaller. So let's just take negative 10. And let's see. So if I take negative 10 here, that's going to end up being 300 minus, that's going to be a positive. So it's concave up. so that's concave up. Let's take 0 here. So if I put 0 in here, that's -1 times 4, that's concave. So that's negative, concave down, and I would assume that this is positive concave up. So my inflection points would be at negative square root of 1/3, positive square root of 1/3. And then if I wanted to graph this thing out, I mean, I could. All I have to do is start plugging numbers into the original function. And you'll see that, and I could do that. So if I put 0 into the original function, I get 0. So 0, 0 is my maximum on this graph. If I put -1 in here, -1 to the 4th is 1 minus, so that's -1. So, and then this is going to be -1, this is going to be -1. And then what do we have? We have it's decreasing. So my graph is going to look like this. Then it's increasing, decreasing, increasing. And if I took a look at the concavity, -infinity to the square root of 1/3, concave up. And then it's going to be concave down. And that concavity changes at square root of 1/3. Because you can see, if we zoomed in, this function is going like this, but then it's going to come back up here. So it changes from concave up to concave down. So that, in a nutshell, is exactly what they want you to be able to do using the second derivative test. So let's try some examples. All right. So what I want you to do, and this is one of the problems off your assessment this week, 15b, it says given 2x to the 4th minus 4x squared plus 1, identify any inflection points and find the intervals where the function is concave up and concave down. So I'm going to let you have some time to work, okay, to find. So you don't even have to do the first derivative test, but obviously you have to take the first derivative to get to the second derivative. But all I'm looking for is inflection points and where it's concave up and concave down. Okay, so give you a couple minutes to work on that and see how you do. But this is one of the problems off your assessment this week. All right. Did you find the intervals where it's concave up and concave down, or are you still working on it? Concave up from negative infinity to 0. Okay. So let me, I'm going to work this out for the students that watch the recording. So if I'm going to do this problem, the first thing I'm going to do is I'm going to find the first derivative. First derivative is 8x to the third minus 8x. Second derivative, 24x squared minus 8. Then I'm going to, that's my second derivative, I'm going to factor out an 8 here. So that gives me 3x squared minus 1. So that gives me 1/3 the square root. No, is this the same problem that we had? So I end up with plus or minus the square root of 1/3. So I'm going to make out, this time I'm going to make my derivative table a little bit larger. So negative infinity to negative square root of 1/3. Negative square root of 1/3 to 1/3, and square root of 1/3 to infinity. So those are my intervals. Oh, did I? Yeah. I was going to say, because you shouldn't have 0 as an interval, right? Yeah, because when you bring it down, you take that, should end up. So then, let's see here. So I'm just going to use negative 10, and I'm just going to use 8 times 3x squared minus 1. I don't even need the 8 because that's always positive. So if I put negative 10 in here, that's going to be positive. If I use 0, that's going to be negative. If I use 10, it's going to be positive. So concave up, concave down, concave up. Inflection points are, so I've got an inflection point at x equals negative square root of 1/3. I also have one at x equals positive square root of 1/3. Where's it concave up? Between negative infinity to negative square root of 1/3, and from square root of 1/3 to infinity. Where's it concave down? Negative square root of 1/3 to positive square root of 1/3. That is it. But if you don't take the derivative correctly, it's not going to work out. All right, here's an AP question off the multiple choice part. It says the graph of y is equal to 3x to the fifth minus 10x to the fourth has an inflection point at blank. Okay, so I want you to tell me where that inflection point is. I'll give you a little bit of time to work on it. See if you can find the inflection point. Letter E. Okay. Now, a lot of kids, they would say letter A right off the bat. And let's see why. So if I was going to do this problem, first thing I'm going to do is I'm going to find the first derivative, which is 15x to the fourth minus 40x to the third. Take the second derivative. I've got 60x to the third minus 120x squared. So I'm going to factor out a 60x squared. So I'm left with x minus 2. So that means x equals 0 or x equals 2 on my x values. So a lot of kids, they would go right for A. Incorrect. So if I make out my second derivative table, f double prime of x, I've got negative infinity to 0, 0 to 2, and 2 to infinity. Now I'm going to use this. I don't need this value. I don't need 60x squared. Why not? This is always positive. Anytime you square a number, it's positive. So this will always be positive. So I really only have to look at x minus 2. So if I take negative 10 minus 2, that's negative. It's concave down there. 0 to 2, so I'm going to take 1. So I put 1 in here. 1 minus 2 is negative also, down. And then I might take 10, that would be positive, concave up. So I have two places where it's concave down and then concave up at 2. So the only value where it's concave up is going to be there. That's why making out that table is so important, because a lot of kids, they always think that, oh, it's going to go concave down, concave up, concave down. Not necessarily. It can be concave down twice and then go to concave up. You don't know. That's why you should always make that table out. Good job. Determine the intervals in which f of x equals x minus 4 to the third is concave down. Okay? So now in this problem, I'm looking at this and it's like, oh no, I got to take the derivative of this thing, but that's not so bad. This is really the chain rule, right? I mean, I've got f of x equals x minus 4 to the third. Well, the first derivative, bring down to 3, leave the middle alone, times the derivative of the middle. Well, derivative of x minus 4 is just 1, so it really is not going to change much. Second derivative, bring down to 2, so that's 6, leave the middle alone, times the derivative of the middle, which is just 1 again. So this is my second derivative. That means that x equals 4, something's happening. So I've got negative infinity to 4, 4 to infinity. That is the extent of my second derivative table. So the 6 is always going to be positive, so the only thing that's going to change the sign is going to be x minus 4. So if I take 0, that's going to be negative. If I take 10, it's going to be positive. So it asks me where it's concave down. Negative infinity to negative infinity to 4. Whew, I was looking at part B and it's like, oh no, that's not negative 4. All right, so letter A, negative infinity to 4, that function should be concave down. Okay, so realistically, this is really very similar to last week's assignment. Last week was first derivative test, which gives us where is it increasing, decreasing, max and mins. Second derivative test gives us where it's concave up or concave down and the inflection points of the graph. All right. Find the inflection points for f of x equals x to the third minus 6x minus 1. I'm going to leave this one up to you. See what you get there. So which one of those answers is correct? Find the inflection point. Is it A or B if you got x equals 0, which I agree with, it is x equals 0. But then you have to plug that back in to find the inflection point, because the inflection point occurs when x equals 0, no question about it. But what is the point on the graph? And that's why, they've got their points like 0, 1 or 0, -6 or 1, 1, 1, -1, -1, 6. Well, we know, yep, it has to be A, because if we put 0 in here, 0, 0, -1. So A is the correct answer. So if I was going to do this, first derivative, 3x squared minus 6. Second derivative, 6x. Set it equal to 0. X equals 0. So I know if I was going to make up my table, negative infinity to 0, 0 to infinity. 6x, so if I put negative in there, it's going to be negative. If I put a positive in there, it's going to be positive. So I've got concave down, and where it changes concavity, I have an inflection point. So 0, x equals 0 is my inflection point. If I put 0 back in here, 0 to the third, minus 6 times 0, minus 1 is -1. So A is the correct answer. I believe this is the last problem for tonight. It says, given the function defined by f of x equals 3x to the fifth minus 20x to the third, find all values of x for which the graph of f is concave up. Okay, so last problem before we head out for the year. The pressure's on. Okay. Any answers there? What part is concave up for this one? And I'm gonna start doing the work. So once you have the answer, just throw it in there. Oh, you got answers, but I can't find the answer choices. Okay. All right. Maybe my answer key is wrong. So if I'm going to take the first derivative test, that's going to be 15x to the fourth minus 60x squared. That's f prime of x. F double prime is equal to, what is that, 60x to the third. Oh, this looks like a problem that we did before also. And then 120x. So I'm going to factor out a 60x. That leaves me with x squared minus 2. Well, a little bit different. So I know 0, and then x squared minus 2, so that's going to be x squared equals 2. So that's going to be x equals the square root of plus or minus the square root of 2. So I really have 3 intervals that I have to check out. Ah, that should have been a 2 there. Okay, did you use 0 in there? Okay, all right, so I'm gonna, so is your answer up there? Is negative infinity to negative squared, so negative, so x is less than, x is, yeah, it doesn't match up. I wonder if my answer key is incorrect here. Okay, let's take a look here. So I'm going to go negative infinity to negative square root of 2, negative square root of 2 to 0, 0 to square root of 2, and square root of 2 to infinity. All right. All right, so now I'm gonna have to use this whole thing here for the second derivative because both terms are going to change. Okay, so if I use, let's say, negative 10, so that's definitely negative there. Negative, that's positive there. So that's going to be negative, concave down. And then I'm going to use 1/2, negative 1/2. So if I use negative 1/2, that's going to be negative there. And that's going to be negative there. That's going to be positive. So that's up. Then I'm going to use positive 1/2. So that's positive. That's still negative. So that's going to be negative. And this is going to be positive. Okay, so it says, given the function, where is it concave up? I'm going to say it's concave up. Square root of 2, x is greater than square root. This looks good here. And greater than square root of 2. Ah, you plugged in numbers wrong. And that does happen. I mean, but I would say 95% of the time it's going to go minus, plus, minus, plus. So usually if it doesn't do that, then I'm thinking to myself, did I do something wrong here? So that's usually how I do it. It's like, okay, if it doesn't go minus, plus, minus, plus, or plus, minus, then I'm thinking something might be wrong. Now, as I said, there's a few times where it will go plus, plus, minus, or minus, minus, plus, but you don't see that too often. All right. That is it. So once you're finished with this week's assessments, and there's 2 multiple choice ones and 1 free response, and the free response, we already did 2 of the problems on the free response, so it should be fairly easy assessment this week. Once you're done, enjoy your time off. All right. You too. Bye.